All right, so in this video, we are going to basically take a look at these rational functions over here, and we're going to find any vertical asymptotes, any holes, and then we're going to sketch the graph based on that behavior. So let's take a look at this first question here. Now, this one is already factored for us, which is a good thing. We don't have to factor ourselves. So if the graph is factored, the first thing I want to do is see if I can cancel anything. In this case, I can cancel x plus 2's. When I cancel these, since there's nothing left in the top, I'm going to write a 1 in the top. And for the bottom over here, it's just an x left. So my final function is 1 over x. Now, this cancellation, anytime you cancel a factor, that always creates a hole. And the x value of the hole is just the solution to the bracket that we canceled, which is minus 2. To find the y value of the hole, we sub in the x value into our simplified equation. So if I do f of -2, that's just 1 over -2, which is negative 0.5. So this is my hole right there. Now, once I have my equation simplified, I have to decide what type of equation is this. If you look at this, this is 1 over x, which is basically a rational function. So in grade 11, there's typically two possibilities, either a rational function or a linear function. Rational is 1 over x, and linear is just y equals mx plus b. So in this case, it's a rational function, which means I can figure out my vertical asymptote. My vertical asymptote is just the solution to the denominator, which in this case is x equals 0. So now using this information, I can sketch out this function over here. The first thing you always want to do is label your vertical asymptote, which is that x equals 0. So that's just on the y-axis right over there. For rational functions in grade 11, we can always assume our horizontal asymptote is at y equals 0. And then I have a hole at -2 and negative 0.5, which is approximately over there. A rational function just looks like this, where you just hug the asymptotes. And then on this side, it's just going to look like this. And you can label the point -2, negative 0.5, which is the hole. So that is the sketch of the function. Let's take a look at some more examples. Let's do this second example over here. This one, we have to factor the top with difference of squares because it's not factored. That's 2x plus 3 times 2x minus 3 over 2x minus 3. And now I can cancel these off. And in this case, I'm just left with 2x plus 3 on the top. And when I do my cancellation, it's going to create a hole. And the x value of this hole is just the solution to the bracket that I canceled, which is positive 3 over 2 or positive 1.5. The y value of the hole, I can sub it in over here. So g of 1.5 is 2 times 1.5 plus 3, which is 3 plus 3, which is 6. That's my hole right over there. Now, if you take a look at this equation here, the simplified one, we have to decide, is this linear or is this rational? You can very easily tell that this is a linear equation. So comparing it to the first example, after we simplified, we had a rational function. Over here, after we simplify, we have a linear function. So now we just have to sketch this linear function over here. For a linear function, you just need to first label the hole. 1.5 and 6 is up over there. And then you need to label the y-intercept, which is just positive 3, which is right over here. And this linear equation has a slope of positive 2 If you look at this slope of this line, it matches that, it's positive 2. And the function just looks like that. You can label the points 3 and 1.5, comma 6. So that's the main difference in this topic. You just need to decide whether it's a rational or linear function and then sketch it accordingly. Let's do another example over here. I got 2 more examples, similar practice. Start with this first one over here. I'm going to start by factoring the bottom with my man method. So if I factor the bottom, I'll get x plus 3 and x minus 5, because 3 and negative 5 multiply to negative 15, and 3 plus negative 5 is negative 2. And I can cancel this bracket over here, and in this case, I'm left with a 1 on the top and x minus 5 on the bottom. So this is a rational function again. We'll start with always labeling the whole if it's possible. In this case, the solution to the bracket that I canceled is minus 3. And if I sub in minus 3 into this equation over here, get 1 over minus 3 minus 5. It's negative 1 over 8, which is basically a really small decimal value. You can calculate it in the calculator. It's negative 0.125. Once I found out the whole, I can just find the vertical asymptote from the solution of the denominator over here. In this case, it's just x equals to 5. And now I can plot this out using the information given. I always start with my vertical asymptote. So vertical asymptote is here at x equals 5. Horizontal asymptote we can assume is always at 0. And then the whole is over here, negative 3, negative 0.125 is right over there, really, really close to the axis. Potentially even closer if you're up to scale. So the graph just looks like this on this side, and on this side it's just the opposite. Just looks like that, and then we can label the point negative 3, negative 0.125. If you want to find this x-intercept over here, you could sub in 0 into this equation. That's just 1 divided by negative 5, which is negative 0.2. Not necessary, but if you want to find it, you could always find it like that as well, just to show you how close this is. Technically, this should all be really, really flat and next to the axis. It shouldn't be this high up, but as you can see, the numbers are really small in terms of the y values. Let's go to the last example over here. I'm going to factor the top with my man method. It's x minus 3 times x minus 2 over x minus 3. These two brackets cancel, and I'm just left with x minus 2 on the top, which is a linear function. I'll first label the whole. So the bracket I cancel gives me a solution of 3. I sub in 3 into this equation. 3 minus 2 is 1. Then I can do a sketch of this function because it's linear. I don't need to find any vertical asymptotes. My y-intercept is negative 2. That's down over here. I have a hole at 3 and 1, which is approximately over there. The slope of this line is just positive 1. And that is how you sketch these rational functions.